Hey guys, okay, so for our lesson today, one of the big underlying principles behind this is proportionality. So, being able to determine that two ratios are equal. For example, here's an example right here 3/4 is equal to 9/12. The way that I know that is that 3 times 3 is 9, 4 times 3 is 12. So if you can multiply the top and bottom by the same number, the same scale factor, and get another ratio, then those two ratios are proportional. So your first activity here is to find pairs of ratios that are proportional and color them the same color. The first one that I see is 5/8, so I'm going to start with that one. I'm going to try to find a ratio that's proportional, meaning I can multiply the same number by top and bottom and I get a new ratio. For this one, I'm looking at the denominator of 8. Which one of these denominators can 8 go into evenly? The only one I see is 24. So what you want to ask yourself is 8 times what is 24? 8 times 3 is 24. What is 5 times 3? It's 15. So I multiplied top and bottom both by 3 this time, and I got a new proportion. A new ratio. They can form a proportion, and they are proportional. So now I'm going to go and pick a different color. I'm going to pick green this time. Let's go with 4/10. What denominator can 10 go into evenly? I see that it can go into 30 and 20. Well, 30 would be times 3. 4 times 3 is not 18, so this is not the match for this ratio. 10 times 2 is 20. 4 times 2 is 8. So since it has the same scale factor, those two are proportional. Let's pick another color. We can go with 7/11. 11 goes into 99 evenly. 11 times 9 is 99. 7 times 9 is 63. This exercise is just to build that knowledge and recall that knowledge of creating similar ratios or proportional ratios. You can go ahead and finish this out. What we're going to see here on the way we're transferring this knowledge into slope is that our rise over run is 2/4. And the way I like to do rise over run, I read the graph from left to right. So I actually do rise first before I do run. I would go up 2. So that's my rise is +2. And my run is +4. You see it's the same numbers here, but when you actually do rise first, then you make sure that you're creating that ratio in the correct order, okay? So 2/4. What I can also see here is that if I go up 1, rise 1, run of 2, 1/2, these two ratios are proportional. I could pick any points on this line, and when I do the rise over run triangle, I'm going to find that the two triangles are always similar. Now, in class, we actually skipped this example, so feel free to cross that out unless you want more practice. Okay, so let's look at this one. I'm going to move my face over here. All right. So again, these people drew the rise and run below it. I like to start from the left side and work towards the right side. And that just helps us to keep our numbers in order. So the first thing I'm going to do is label the dots that I see. I see here's a point. None of these cross exactly until right here. So I want you to notice how this point, it actually lines up exactly with an X value and a Y value. That's where you want to plot your points. Like this is not on one of those intersections, so we don't want to count that as a point. We are not calculators, and we cannot precisely determine where that is on the line, so we don't like to count that. We're just going to go with our ones that are exactly on that intersection. So that's your first step. Determine where your points are. The next step is to create those triangles. So I have rise of +3. Since I'm going up, it's positive. And then to the right is also positive. So over here, I'm going to write rise over run. And I'm going to do a little line in between there. Rise over run equals 3/2. Another triangle I can find, and you can pick any 2 points. I can go up 6/4. That ratio would be 6/4. I want you to determine, are these ratios proportional? Can I multiply them by the same scale factor and get a new ratio that's exactly the same? Yes, I can. I am doing 3 times 2 is 6, 2 times 2 is 4. So yes, those are proportional. What we did in class at this point, I had the students find one more triangle that would be proportional. A lot of people chose this one. Up 9/6. And the pattern I want you to see is that between any 2 points, so it could be these middle points, it could be this point and this point. No matter what 2 points I choose, the slope, the rise over run, the slope will be proportional. Okay, so let's try a new one. And I was trying to see if I could do a little trick on erasing. I don't think I can. I hope y'all are having a good day. I miss all y'all's beautiful faces. I miss ya, miss ya, miss ya. There we go. All right, so I'm going to kind of ignore the line that they drew. I'm going to show every point that I see, every exact point. I see a pattern here. You'll see a pattern on every one, and that's what your slope is, really. Like if you notice here, our pattern was like that we're going up 3/2, up 3/2, up 3/2. That's your slope. This one we're going up 1/1. Up 1/1, up 1/1, up 1/1. We have a lot of points to choose from, okay? If I'm going to replicate the triangle that they did, I would be going for a rise of 7 and a run of 7. So rise over run is 7/7. And that reduces to a slope of 1. What do you notice about that? We talked about between each point, the smallest version of the slope we found is up 1/1. Our slope is 1. Ah, it all makes sense. Okay, so you can choose any. I want you to choose 3 more triangles on your own. So I want you to pause the video, find 3 more triangles that you can create, and write your ratios out here. All right, I hope you paused it. I am back. I'm here. I never went anywhere. Okay, so I'm going to show you some examples. You could do up 3 over 3. You could do up 4 over 4. I could even start at this point, go up 10 over 10. The thing you're going to notice is every ratio I make, if I simplify it, it's going to end up being 1, which is that's our slope, is 1. All right. Let me erase this. All right, last one I'm going to do with y'all today, and this one is a little different. If you notice, and what we've talked about before, is that when the slope is going down to the right, it's a negative slope. The ones we've seen so far going up to the right, that's a positive slope. This one is clearly different, right? Okay, let's go back and look. We have up to the right. Now we're going down to the right. So when we figure out our rise, and usually when we think of the word rise, we think of going up, but in math, this rise can actually be negative. So rise just refers to the change in y. Sometimes it changes up, sometimes it changes down. That's okay. Totally cool. Okay, so I've labeled all my exact points. I see a pattern. I don't know if you noticed the pattern. Remember that pattern is actually the slope. I'm going down 1 over 2. Down 1 over 2. Down 1 over 2. So my rise over run is down 1, so negative 1 over 2. And you can pick any 2 points on this line, anywhere on this line, and that fraction will reduce to negative 1 over 2. It's like magic. Okay, so I'm going to pick 2 random points. I'm going to go from here to this one, this last one. So I'm going to go down 4 over 8. And I hope you see this relationship. I can multiply the top number by 4. Negative 1 times 4 is negative 4. 2 times 4 is 8. Bam. They are proportional. So what I want you to do on your own right now is find 2 more triangles. Write your ratios out here, your rise over run. When you're done, you're going to click the 3 dots, download, and go back to your Canvas week 4, day 4, and submit that assignment. I love you guys. I hope y'all are having an amazing day. If you need anything at all, let me know.